How's everyone doing this morning? Feeling good? Late in the week? People having a lot of fun? Lots of parties? I don't know about you, but I'm exhausted. All right, let's get this started. My name is Jillian. I lead the community advocacy team at DBT Labs, and I will be your host for today's session, Modern Data Teams. So speaking of being tired, feeling worn out, I caught Abhi on Twitter last night. I don't know what time it was, 14 hours ago from when I took this screenshot. He said, "This is great fun and all, but I can't wait for Coalesce to end so that Convalesce can begin." I have a feeling that resonates with a lot of us here. So I had the pleasure of getting to know Abhi over the past year. Or Abhi, as I learned, over the last year on this little topic that blew up as data topics do these days. Has anyone here heard of the data mesh? Yes? No? Yeah? So amongst the uproar of buzzwords, shit posting, Abhi's calm and resonant voice being like, yo, can everyone please chill out? This is actually an effective framework for organizing your data teams and process. And if I recall, at one point, he brought this to Twitter because his team was asking him things like, so is data mesh Scientology? Because that's what this sounds like. All right, so in his last role, Abhi led the growth and analytics team at Flexport before the Amazon heavyweights took over. And he was one of the most sound and comprehensive reads on scaling modern analytics teams effectively, as well as infrastructures. So I'm really excited for you all to hear him speak today. Real quick, before I hand it over, just a few reminders about participating. All of the chat conversation will be taking place in the DBT Slack in the Coalesce the Modern Data Team channel. You know the deal, hopefully at this point. Please jump in, ask questions, make comments, react at any point. And if Abhi isn't yet convalescing, he will jump into the channel afterwards to answer all of your questions. So with that, please give it up. Bring a warm welcome for Abhi.
Cool. Sounds good. Hi, folks. All right, this is working? Sort of? Okay, cool. All right. Hi, I'm Abhi, and we're going to talk about the modern data team today. We've heard a lot about the modern data stack, and now we're going to talk about what that means for teams. So to kick things off, to set context here, look, people ask about how to structure data teams all the time, right? If you hang around in the water coolers on Slack, on Twitter, on wherever data people hang out, this is a very frequent refrain. It's an evergreen topic. How should I structure my team? Where do I report into? How does my team work? And the reason it's an evergreen topic is because it's so context dependent, right? There isn't a single answer. It depends on your company, your industry, your technology stack, what you can do, what you can't do with your tech stack, the constraints and capabilities. So there isn't a bulletproof answer, there isn't a single model, and there's nothing I'm going to talk about that you can lift and shift. All we're going to talk about today is we're going to muse. We're going to talk about how to think. We're just going to talk about how I reason about these things, and hopefully that helps you reason about your specific context as well. So the thesis here is, look, tech is changing, right? What's most common to all of us is that the tech is changing. This is what's changing the most rapidly. This is the theme of this conference. And teams need to adapt. Teams can't work the way they did in, I guess, the pre-modern data stack world. So what should that look like now in terms of how we're structured, what the roles are, what the processes are, what the orientation is? This I could talk about for several hours. I'm going to try and densely talk about it in the next 30 minutes, so hang in there. So a good place to start is what has changed. Again, we're going to do a lot of musing here. So what has changed? So what has changed? So look, we've been talking about the modern data stack all week. This term, I'm sure a lot of us are sick of. It generates more heat than light. It's definitely not a vendor map, right? That's what the vendors would have you believe, that I'm in the modern data stack and you're not. To me, the modern data stack is that over the past decade, we've seen these 5 big forces. We've seen ingestion get easier, transformation become diffuse, the warehouse become more central, abstraction interfaces rise up, and the democratization of what we can think of as advanced analytics, advanced kind of scientific use cases, right? If modern data stack means anything at all, it means that the trends that capitalize from these 5 forces that we see expressed in the vendor maps that we see today. So let's talk about each of those briefly. Number 1, ease of ingestion. Look, it's just never been easier to ingest data, right? Whether it's a streaming source or a batch source, whether I own the source or whether it's third party, it's never been easier, it's never been more of a solved problem, and it's never made less sense for data engineers especially, or internal employees in general, to own the EL pipeline aspect of the lifecycle, right? And that wasn't the case 10 years ago. It wasn't the case 7 years ago, but it's definitely the case today. Number 2, diffusion of data transformation. Transformation is also easier than it's ever been before. And look, DBT drove a lot of this, right? SQL as a lingua franca means that we were able to bring on analysts and business users. At Flexport, we had plenty of business users and power users writing DBT models. The embracing of data ops into DBT, data lineage, encoding metadata, testing, all of these things mean that we can bring on software engineers who find it more attractive, more ergonomic, easier to adopt in their workflows. And what this really means is that data engineers, though it used to be 7 years ago that ELT pipelines were all owned by data engineers don't need to own the T pipelines either, right? The T pipelines now increasingly become diffuse as well. Number 3, the centrality of the warehouse. In 2022, the warehouse is the center of the data universe, right? It powers everything, and that wasn't the case even 4 or 5 years ago. Data warehouses have become more powerful, they've become more expressive, they've become more integrated, and that means they power everything. They power all the analytics and science use cases. They power increasingly operational use cases. Reverse ETL wasn't a thing 3 years ago. They power increasingly data applications where you can basically go to market with your internal users or your external users with data value, with data products, with a much shorter time to release than you ever had before. And that means that this is now our treasure chest. This is now the most valuable artifact that we have, and the most important high leverage thing that we can do on data teams is to preserve the quality of the artifacts that we encode into the warehouse. Abstraction interfaces. We've talked about this a lot this week, right? The semantic layer, the metrics layer. I won't rehash all of it, but I will say the implication here is, again, we're democratizing transformation. Why are we democratizing transformation? Well, because it's great that SQL has enabled more folks to engage with DBT core, shall we say, with model generation in the warehouse, but it's not enough. And the semantic layer and the metrics layer mean that business users have yet another interface to encode, to engage in this, this meaning making, this meaning sharing that we're hoping to diffuse throughout the enterprise. It also means that we democratize consumption. Self-serve is more possible than it was before, because in the world before, self-serve was really a function of how good your models were, and now those models are becoming more expressive. Data's harder to use incorrectly, right, with the emergence of curated semantics layers and metrics layers. And democratization of advanced analytics. So science use cases are now increasingly democratized. 7 years ago, you used to increasingly need, or used to still largely need, data scientists, specialists that were statistically trained to run experiments, right? If you wanted to do multivariate analysis, you would need a statistician for that. If you wanted to do time series forecasting, you would need a statistician for that, someone who was specially trained. That isn't the case any longer, right? An analyst with Profit open on a notebook can get pretty darn far, and this is true for an increasing swath of use cases where more and more of these science use cases become standardized. That's what's happening, right? Those are the forces that we see when we talk about the modern data stack. It's all the vendor tech ecosystem really kind of distills into those forces that we're looking at. And those also map to kind of this classical data science hierarchy of needs that all of us have seen, right? We collect data, we move it, we transform it, we expose it to internal and external partners, we optimize how we run as a company using that data, and then the nirvana state is that we actually use that data to drive value back for end customers, right? And our forces map to every layer, right? What's been gratifying in the modern data stack of the past 7 years is that we are opening up leverage at every layer of that stack. Not evenly, there are some holes, some places are more expressed than others, but we are opening up leverage at every layer of that stack. Okay, so what does this mean for data teams? The questions we're trying to answer when we talk about what this means for data teams, and again, nothing is lift and shift, we're just thinking, are the questions on the right. Who makes up our teams, right? What constitutes our teams? Where do we invest? Where do we double down? Where do we prioritize? And how do those teams work, right? What are the processes, the mechanisms that bind those teams? Those are the questions that we're trying to answer. The meta question that's really important here is leverage, right? The purpose of a team in any company is to maximize leverage for its company, right? For its broader organization. The question of how we structure these teams, how we orient them, is really a question of how do we respond to where leverage is shifting? Where is there new leverage from technology? Where is leverage change with technology? How is leverage shift from our plates to other plates? And that's really the meta question that animates how we think about these questions on the right. So let's start with who makes up our teams. The halcyon days of, again, I say like 7 years ago, 10 years ago, so much has happened in just 5 to 7 years. But 5 to 7 years ago, this was basically what the landscape looked like, right? You had data engineers who basically wrote ELT pipelines. You had analysts that were largely working on reactive dashboarding and reporting. And you had data scientists who were opportunistically used for some advanced use cases, right? Some of the advanced analytics use cases we were looking at. This has already started to change, right? This has already broken in the past few years. For starters, there's no analytics engineer on here, right? Which is relatively new, and DBT has helped to bring that about. So these have changed, and the question is, why are they changing, and what is that going to look like? Many of you could give very different answers than me, but we're just thinking, right? We're just reasoning through this. And our leverage first, and so I'll just talk to you about kind of how I see this shifting, how I see this has already shifted, and where I see this is going, again, based on kind of a leverage first view. So we can start with data science. Again, citizen science, it used to be that you needed a data scientist for a lot of these use cases, right? For experimentation, for forecasting, what have you, and that isn't the case anymore. The leverage has shifted. Data scientists no longer have high leverage in doing those applications, and now the leverage is on the frontier. These very bespoke, particular things, these harder, thornier problems that are very specific, maybe context-specific to the company, that just haven't been productized, maybe cannot be productized. The opportunity for data scientists is no longer where they used to be. It's now on the frontier. Similarly, those data scientists typically productized, full-stack data scientists productized and specialized in productizing their applications. Maybe it was a forecasting application in R Shiny. Maybe it was an ML application as some kind of small Flask service. That's no longer necessary as well because of the centrality of the warehouse, because of what the warehouse allows us to do. Instead, here too, the leverage is no longer where it used to be. The leverage is on the frontier. If there are things that, for some reason, a warehouse-centric approach cannot productize efficiently, cannot productize cost-effectively, that's where MLE comes, and those full-stack data scientists that want to specialize on productization focus on the frontier where the warehouse can't touch. The case for analysts looks different. Where data scientists are kind of more retreating from leverage that's been lost, I see analysts going towards leverage opportunities that are newly created. I think of these aren't job titles, but I think of these as kind of two buckets, kind of an operational bucket and a strategic bucket. On the operational side, semantic interfaces, great. Semantic layer, awesome. Metric layer, awesome. But these things need to be governed, right? It's power, but that power needs to be wielded. And as these tools get more sophisticated, they need governance, they need someone with the guardrails, and they need someone to help operationalize this in the business. What I see as that first opportunity for analysts to specialize is on operationalizing data in the business. That means really doubling down on governing that semantics layer, governing that metrics layer. Yes, focusing on reporting, and not so much the capital A analysis that analysts want to do, that typically analysts aspire to do, but really focusing on the value of operationalizing data-driven motions. On the other side, there is some scope, of course, for capital A analysis, but that capital A analysis is fundamentally a different track. One of the reasons why we haven't seen capital A analysis where people are off doing analysis and going and doing deep dives take is because we've conflated these, right? And deconflating means that we allow people to specialize on that operationalizing day-to-day tactical piece, and we allow other folks to use some of the leverage that's been created by things like the citizen science tools to take a longer view, to take a more exploratory view, to take a more strategic view on how our business partners should orchestrate their work writ large. Data engineering, we'll touch on briefly. Look, data engineers used to write ELT pipelines predominantly, right? A lot of that has become either obsolete, taken over by technology, or become diffuse. The opportunity here, as we know, is on the left, and we're going to see this increasingly, the title data engineer is going to go away. On the left, we see basically data infra, data platform, where you're building bespoke tools, bespoke platform components for truly bespoke needs, where the existing tooling doesn't work. And on the right, you have analytics engineers. Now, this is a conference. I think there's 5 or 6 talks on analytics engineering, so I'm not going to belabor the point. The only framing that I'll add to what everyone else has said, I'm sure there's been great talks, is I think of analytics engineering as a noun and as a verb. And typically, we talk about analytics engineering as a noun, right? It's something that someone is. It's something that analytics engineering is what analytics engineers do. But analytics engineering is also a verb, and it's a verb that as it's the verb that as diffusion of transformation takes hold, it's a verb, it's a process that everyone in the enterprise participates in, right? And if you think of analytics engineering as a verb and as a noun, the role of analytics engineers as a noun is really to help that verb work, right? Is to help ensure that meaning making stays on rails throughout the enterprise as more and more folks are participating in the process of data transformation. So what you end up with is a modern data family that looks very different, right? Again, based on kind of how we see leverage shifting, you have a DSML family, an analyst family, and a data eng family that are starting to break. And as leverage continues to shift, you're going to see that leverage continue to manifest in continuing subdivisions of these functions. So, okay, so the next question is, great, we have our teams. Now, taking a leverage first view, where should we invest? Where should we prioritize? Where do we focus these folks? And here too, a leverage-first approach, there's 2 ways we could look at it. One is, hey, tech has created some leverage, let's go use it, and let's go double down. Another is, hey, tech has missed some spots, right? There are places where tech doesn't work. And to really harness the leverage that tech is creating, we need to have humans we need to have our teams focus on the things that tech isn't serving. And in the modern data stack, that looks like 2 big buckets. Modeling, the actual process of making meaning and making models that are expressive, right, that are scalable, that are durable, and the analysis portion, right, where we take all of these artifacts, we take these abstractions, we take the exposures, and we actually bake them into the company and we do analysis. Focusing on these is focusing on enabling the leverage to come through. So we're going to focus on just one of those, because I probably don't have that much time. So how do we work? Let's zoom in on modeling, right? Like, how do we make modeling really work in an enterprise, given the kind of teams and the kind of decompositions that we've seen? So we're going to zoom in on the product lifecycle, and we're going to talk about how to position a team and how to orient that team within the context of a classical product lifecycle. Reductively, you can think of a product lifecycle, like I'm talking, making a feature as ideation, product design, product development, right? I come up with an idea, what I'm going to do, let's say as a PM, right? I design a feature or scope, and then engineering develops it. The problem with this lifecycle is that data is usually an afterthought. If we were to make data a forethought, we would recognize that this product lifecycle creates data side effects and implicitly uses data in the process, but we need to make that explicit. On the ideation side, we use data to come up with the cut lines, right? How do we focus our ideation flashlight, and where do we draw the cut lines for what we work on? How do we know what kind of field we should work within? On the design side, every time a feature is designed, every time a PM says we're going to do X, there are 3 data side effects that are going to be introduced into the process that we think about only implicitly, but never explicitly, and that creates debt. Those data side effects are either you're going to be creating new data, right? Have a new feature, so it's actually throwing off new data. You are mutating old data, right? Some business processes have changed, and the ways we represented data before no longer are durable. Or you're asking new business questions of data, right? There are these 3 hidden data side effects that then, when the feature is developed, right, when engineering actually instantiates the feature, those side effects become real, right? And the problem with most product development life cycles is that these side effects compound and compound and compound, and they happen in trickles, and pretty soon you have models that have substantially drifted, right? You have models that are no longer expressive because we weren't treating those side effects as a first-order priority. So what would it look like, again, thinking about leverage, thinking about our teams, thinking about focusing on making modeling work well, what would a better product lifecycle look like? So starting at the top on the ideation side, it looks like an elevated role for, I mentioned those kind of strategic analysts. It looks like an elevated role for an analyst to particularly focus on ideation, ideation as an input into the PM process. That means looking at not just data that we have inside the company, but also outside the company. It means analyzing trends. It means looking at competitor data. It means looking at market data. It means thinking about things that management consultants think like Porter's 5 forces and competitive dynamics. It means taking a broader view of, and using citizen science tools often to do so, of what should we work on and in what order. That ideation, that's really data-driven ideation, then goes to the PM land, right? And this is where the process starts today, and it's where the process will continue in kind of this more modern life cycle. The PRD, the PM codifies, expresses, what feature they're going to work on. They take these ideas and they express them in what's typically called a PRD, right? A product spec, a product requirement stock. And if they don't do that, then they need to. They need to codify, they need to formalize it. What is different about the process we're talking about here at this stage is that every PRD is associated with an ARD as well, an analytics requirement stock. And that analytics requirement stock is driven by that second type of analyst, that analyst that's focused on operationalizing how we work in data, right? That's focused more on that tactical. That ARD is how we make those side effects more explicit, right? Especially that third side effect of what new business questions we're going to be asking. Every PRD, before it gets any further, before it goes to EngLand, needs to have explicitly, this is what we think of as new data we're going to be creating, functionally, right, logically. This is how we may expect data to mutate based on how business processes have changed. And these are the new business questions we're going to be asking of data. Those requirements, again, now those side effects have been made explicit, right? Those requirements then head into EngLand. Classically, engineering has an engineering requirement stock. They take those requirements and they produce them, right? And typically, if you're not thinking about data side effects, this is where we kind of clumsily, implicitly just encode these side effects without thought about durability, without thought about scale. And the difference here in this process and why how we address kind of the modeling shortcomings, the side effects shortcomings that we see in the classical process is by elevating the role of the analytics engineer. So as part of the analytics, as part of the engineering requirements process, just as we had an ARD associated with a PRD, as part of the ERD process, the engineering requirements process, we have what I call a DDD, a data design doc. And that data design doc is really the analytics engineer working to define, hey, we have these side effects that have been specified. How do I rationalize them? How do I evolve our domain model gracefully? How do I think strategically right now about how to define data contracts? Right now about how to, as part of the producer process, of how to evolve our schemas, of how to build analytical models that are going to be representative of the kinds of questions, the kinds of side effects that have been specified in the ARD. That then goes, once that's accepted by engineering and AEs working together, that then goes to execution, right? Where that data, those contracts are reified by engineers. Those contracts are validated by analytics engineers. And then the next magic happens, which is that the analytical data modeling here that you see is shared, right? Because it can be shared. The job of an analytics engineer is actually more architectural. It's more strategic. It's not just a SQL monkey, right? It's not just someone that writes SQL, and they don't even need to write SQL. What's most important is that they're thinking strategically. They're thinking like data architects as part of the producer process about how do I manage these side effects, right? These data side effects in a graceful way. And so the analytics engineers here specify how analytical data modeling should work. They specify kind of the guardrails, the governance essentially of those analytical models, and then they share the responsibility of actually making those models. Maybe they're the ones that make the models, maybe the software engineers make the models, but the work of modeling is orchestrated by that analytics engineer. Once that's done, right, great, you have these features. Right as the features are being developed, we're being conscious about how they're going to be used. We're creating data contracts to support that. We're creating analytical models. On top of those analytical models, we return to our more operationally focused analyst, right, who is working to then do BI development, but also work on those abstraction interfaces, right? Because data cascades through layers. There's the physical model in the application. There's the domain model. There's events and the contracts between that and the lake. There's then the analytical models. Then on top of that, there's a semantic layer and the metric layer and then dashboards, so on and so forth. So we're all taking pieces. We're being very explicit about which pieces we own. And on top of the analytical data modeling, the operational analyst is now focusing on semantic layer, governance of semantic layer, that metric layer, and the exposures, and they're developing the BI, right, tactically, and expressing that third side effect, right? What business questions do we have that they called out in the ARD? They're realizing that in this next stage. And then finally, we start analysis and iteration, right? Analysis can now be much broader, right? Because of some of the tooling we've enabled, because if the BI analyst here, the operation analyst is doing their job, we're making the metrics layer ergonomic. The PM can self-serve increasingly. The product analyst can self-serve on thinking about the next round of iteration, more forward-looking strategy. And all of that bakes back into the PRD process, right? This is a very important chart to me. I probably don't have time for another one. Yeah, I don't have time for another one. You can find me in the hallway. There is another life cycle that I'm happy to chat with folks about, and that is the business life cycle, because we talked about kind of how this works on the product side. There's an analog for how we can work with business teams and how we can work with the kind of execution life cycle of operationalizing how we make data-driven decisions. Happy to talk about that as well. But the punchline, folks, is this was dense, right? There was a lot. I could have talked for another hour. The punchline is, look, it's not a lift and shift model, but there's a lot of thinking that goes into that model. That's not how most teams work. I see a lot of teams. That's not how most teams work. That's not how most product orgs partner with analysts. That's not how most engineering orgs partner with analytics engineers. But it's powerful. And it's a model that makes use of the leverage that technology has provided. And it's a model that's now more viable because of the leverage that technology has provided. And it's that kind of thinking that I want to leave you all with, right? Technology has changed. Teams need to change with it. And that means we need to change what functions those teams represent, where we invest, and the mechanisms, the processes that those teams are governed by. And to do all of that, the key word of the day is leverage, right? Where is leverage shifted, and how do we best capitalize on that leverage? All right, folks, that is it. Thank you.